So we learned that the law of sines could be used to solve triangles, not just right triangles, but any triangle where you know two angles and a side. You can also use it to solve triangles where you know two sides and a non-included angle, also known as SSA. It's called the ambiguous case because we can't readily know how many solutions there are, but we can figure that out. So again, we're going to be given two sides and the non-included angle of a triangle. And we want to be able to find the missing parts. And we will see here, as we investigate this, that we could have either 0 solutions, 1 solution, or 2 solutions. And so what we have down here is a little diagram. And when I draw these diagrams for a side-side angle case, I like to start with a reference line, a horizontal line. So I like to set this up the same way each time. So I start with a horizontal line, then I sketch my angle. So that's going to be my given angle, the A, and then the two sides. So I would sketch in side B and side A. And really the important one here that we're going to look at the most is side A. And so what we're going to do, we'll look at a couple cases. Case 1, where angle A is an acute angle, as shown right now. And then we'll look at case 2, where angle A is an obtuse angle. Looking at case 1, I have 4 different situations, and we're going to look at each of those. The first one I have A is less than H. So first of all, I have to tell you what H is. So you take this vertex where B and A, side B and side A, meet, and we're going to go from there down to my reference line. So once again, angle A is set, side B is set, and side A is set. Those lengths are stay the same throughout, and this angle stays the same. So we're going to look at this first case, this situation, then the situation where A equals H, and then this one, and then this one. So right now it's set up so that side A is less than H right here. So when we look at this, we want to solve a triangle where side A is less than H. Well, as I swing this side here, we notice that this doesn't even form a triangle. We need this to reach this side here, this third side, this reference line, in order for it to sort of form a triangle. So we notice, again, one important thing, that if A is less than this H here, and I use H for height, as we'll look later, that there's no solution. There's no triangle formed. So as soon as you're able to observe that, you know there's no solution. Now we're going to look at the case where A is equal to H. So A is equal to H. What's happening here? Well, as we swing this down, again, we want a triangle to be formed. And notice there's only a triangle formed in one spot, and that's where A is actually the same as H, where it reaches right down to that reference thing, that reference line. And so we notice here, if A is equal to H, we have exactly one triangle that can be formed. It ends up being a right triangle. Now let's look at the case where A is greater than H, but we still want A to be less than B, because that's a fourth situation here. So we want A to be greater than H, but less than B. So I'll swing this over here and show that it is less than B. And so what happens here? Well, here we have a triangle formed right here. So there's a solution. We could find the missing parts in that triangle. But if we come over further, we see that there's another triangle formed. And so in this situation, we could have two solutions, or we do have two separate solutions. We have one when A hits the reference line there, because here's our given angle, one of our sides, and our second side. So there's a triangle, but we also have another triangle formed when we still have this angle, still have the side length B, and still have the side length A. So in this situation, you could have two solutions. and we will learn how to solve both of those triangles. And then last, for case 1 here, when it's an acute angle, we're going to make side A longer than side B. And we notice, well, here's one triangle formed. We swing this around, and you might think, well, there's two triangles formed, but when this hits over here, angle A is no longer part of our triangle. So this still is just one solution over here, where we have angle A is set, side B is set, and side A is set. And so in this situation where A ends up being longer than B, there's just one solution. And we can just use the law of sines to find those missing parts. Now what we're going to do is we're going to look at when A is an obtuse angle. We'll no longer need this height here. So we're going to swing this out. So angle A is an obtuse angle, to make it even more obvious. And we're going to look at just two things here. If A is less than or equal to B, well, here A is less than or equal to B. You notice here we can't form a triangle. So if A is obtuse, angle A is obtuse, and this side across from it is less than this side, there's not going to be any triangle formed. Well, what happens if A is greater than that? A is greater than B. Well, there's going to be one triangle formed right there. We can make this even larger if we want to. And we can see, well, here's one triangle formed. If we try to swing across here, this obtuse angle A is no longer part of the triangle, so that does not form a triangle when it's over here. And so we see that we have one solution. So there are the different cases when talking about a situation where we know two sides and a non-included angle. I want to end with one more thing here. We'll put this height back in and we'll make this an acute angle again. We can even move this down here. It doesn't really matter that much. But let's take a look at this. So in a situation side-side angle, we'll be given a length or an angle measurement for A, maybe 75 degrees. We'll be given a length measurement for side B, and we'll be given this. So we'll be given three numbers in this situation, and H is not one of those numbers. So I have all these things compared to H here, but that's not even given. So how do we compare those? Well, we can find H because what we have here is a right triangle. So we have a right triangle there. And since we have a right triangle, we have an angle, we have a side, and we want to find H because we don't know this length. And so how do we find H? Well, we use our normal trigonometry. We have sine of A is equal to opposite over hypotenuse. So what's the length of A? Well, sine of A equals H over B. Well, we want to know what H is, so how do we solve for H? We multiply both sides by B, and we get H equals B times the sine of A. So we can pretty easily find this length right here. H is simply equal to B times the sine of A. So up here when we're doing these comparisons, if A is less than the height or A is equal to the height, A is greater than the height, we don't have to use H there. We actually know that H is equal to B times the sine of A. So we can look at different comparisons here. A is less than B sine of A, when A is equal to B sine of A, and A is greater than B sine of A. And so the key is when doing these problems, especially when you have this the fact that angle A is acute, the key is to find what this height is. So when we start these problems, we're going to find this height using the fact that sine of A equals h over b. And so if we know the height, we can compare side A to that height. So again, the first thing we'll do when we come across problems like this, find the length of h and see how A compares to h.